Welcome to our video on standards in carbon capture and storage, with a focus on ISO 27914 for geological storage and ISO 27913 for pipeline transportation. It's prepared by Dr. Qureshi from National University of Singapore. He specializes in the area of CCUS and have already completed several projects with industry. Please don't forget to subscribe and like so we can build a strong community and continue our CCUS research. Standardizing CCS is vital for global climate efforts. ISO 27914 guides safe, long-term geological storage, while ISO 27913 focuses on pipeline safety. Together, they ensure operational integrity across the value chain. As CCS deployment accelerates worldwide, following these ISO standards is essential to maintain environmental safety and integrity as the industry grows. The CCS value chain involves three main stages: capturing CO2, transporting it through pipelines under ISO 27913, and final storage according to ISO 27914 standards. In this part, we examine ISO 27914, which establishes the international requirements for the geological storage of carbon dioxide. ISO 27914 provides a framework for safe geological storage. It covers site selection and integrity, while excluding EOR processes, to minimize environmental and health risks globally. The storage project lifecycle includes four key stages: initial site selection, facility development, active operation, and final post-closure monitoring. Choosing a site is fundamental. ISO 27914 requires reservoirs with adequate porosity and permeability, protected by an impermeable caprock to ensure long-term containment. Site characterization involves building dynamic models from high-resolution 3D seismic data and core samples to accurately simulate plume behavior and pressure changes. Maintaining containment requires evaluating caprock competence, ensuring fault stability by managing injection pressures, and modeling geochemical reactions over time. While construction is critical, we use corrosion-resistant materials, specialized cements, and ensure zonal isolation to prevent migration, while designing for eventual secure abandonment. Risk management plans are mandatory under ISO 27914. These include identifying potential leak pathways and preparing corrective actions for any pressure anomalies. During injection, operators must maintain pressures below the caprock's fracture limit. Continuous monitoring triggers automatic shut-in if parameters deviate from safety thresholds. To verify storage, projects utilize a combination of techniques, including downhole measurements, 4D seismic surveys, and groundwater sampling to track plume migration. Finally, the closure phase involves decommissioning infrastructure, verifying stabilization, managing long-term liability transition, and restoring the surface environment. The goal of ISO 27914 is permanent, safe geological storage, aiming for over 10,000 years of containment to effectively mitigate climate impact. Now we transition to Part 2, which covers ISO 27913, the standard for pipeline transportation systems designed specifically for carbon dioxide streams. ISO 27913 addresses various system types, including onshore and offshore pipelines, and provides guidelines for retrofitting existing infrastructure for CO2 service. This standard covers both gaseous and dense phases of CO2. Dense phase transport is preferred for large volumes due to its higher efficiency and lower pressure drop. Stream quality is strictly regulated. Impurities must be minimized. Dehydration is crucial to prevent corrosion, and continuous monitoring ensures transport specifications are met. ISO 27913 clearly defines system boundaries, from the capture inlet valve through the main infrastructure, ending at the storage facility's injection manifold. Design criteria for pipelines focus on high-pressure dense phase flow and mitigating fracture propagation through reinforced wall thickness or specialized fracture arresters. For materials, carbon steel is used when the CO2 is dry, while corrosion-resistant alloys are employed otherwise. Elastomers must be resistant to explosive decompression. Operational parameters must be carefully maintained to ensure flow assurance throughout the transportation network. Modern CCS networks often feature hubs that converge streams. ISO 27913 requires careful pressure matching and accurate metering to ensure compatibility and system safety. Maintenance protocols include regular PIG inspections for integrity and precise modeling of blowdown procedures to prevent thermal shock and embrittlement. Safety is paramount. Regulations mandate dispersion modeling for leak detection, safe setback distances, and coordinated emergency response plans. The interface between transport and storage is critical, requiring alignment of delivery and injection pressures, as well as strict temperature control to protect the reservoir. Ultimately, standardization provides the essential foundation for safe, scalable, and global decarbonization efforts. Thank you for joining us for this module on carbon capture and storage standards. We hope this has been informative. If you are interested in collaborating on research, consulting, or technical training, please feel free to reach out via email or connect through the professional network channels listed.